Okay, so we have this public event this morning starts with a project overview where I will explain to you what the project is about, what our goals are, and what we try to achieve in the next 2 years. After that, the different project partners will introduce themselves to you, showing their capabilities, showing their role in the project, and also who is working on the project itself. So yeah, the project is called LUWEX, and the full title is Validation of Lunar Water Extraction and Purification Technologies for in-situ propellant and consumables production. But in the following presentations, we only call it LUWEX for simplicity. We target water as a space resource with our project because water is essential for sustainable space exploration, and water is also the most versatile resource that we can find in space. Because water by itself is required for astronauts, for drinking water and for hygiene water, but also we can split water into hydrogen and oxygen, which are both also very, very useful resources. We can use oxygen just for the breathing of the astronauts, or we can use hydrogen and oxygen together as propellant for landing vehicles or for spacecrafts. And we can also use the combination of water, hydrogen, oxygen, so electrolysis and fuel cells as a means to store energy. So as you see, finding water and using water on a planetary body is very, very useful, very essential for future space exploration. We focus now a bit more on the moon because that's our neighbor and it's the target of the future space exploration missions in the coming decade. And it will also be a precursor for future Mars missions. And there is very strong evidence that there is water on the moon. The early results date back into the 90s with missions like Clementine and Lunar Prospector, who found evidence of water and hydroxyl molecules on the lunar surface, which was again confirmed with the measurements from the Chandrayaan-1 mission in 2009 and the LCROSS and Lunar Reconnaissance Orbiter also in 2009. After evaluating data from the moon mineralogy mapper on Chandrayaan-1 in 2018, it could be even confirmed that there is water ice in some locations on the moon, especially in permanently shadowed craters where the temperatures are so cold that the water stays frozen and it's not evaporating into the vacuum. What is still not known yet is the exact amount of water that is available, since all the measurements so far were done with orbiters, so with remote sensing, remote imaging devices, and actual ground data from missions that drill into the ground is not yet available, but there will be missions like the Viper rover in the next decade that will drill into the ground and look for water there. We're also not sure yet how the state of the water is on the moon. So is it frozen water ice? Is it trapped water or hydrated minerals? Probably it's a combination of all of that. And if it's water ice, it's still unclear if it's it's single ice particles, or is it more like the ice is a compound with the regolith, something like concrete, or if it's trapped water molecules. So that's still also something that is not known yet, and that can only be found with rovers on the ground making direct measurements. However, since we have the remote sensing images and data, there is, and we also have simulation models, it's theoretically possible that there's up to 20% of the weight in a crater is water ice. but that's really the optimistic upper boundary, so to say. So the real value might be more closer to 5 or 10%. So we target with our project the extraction of this water, or the precursor experiments for extracting this water and purifying it. And the project objectives for that are the development of those technologies for water extraction, purification, and quality monitoring. And for that, we plan to design and manufacture an integrated validation test setup to provide a proper test environment to test and validate those technologies in a relevant environment. And we not only want to test single technologies, but the whole process chain. So really connecting the different subsystems from extraction to liquefaction, purification, storage, and quality monitoring in between. So we really want to connect the whole process chain and test it in our project. So that's the process chain I talked about. So we start with the water ice deposit on the left side, and we have the extraction part, then the liquefaction subsystem, the purification subsystem, and the storage. And after the storage would be, for example, the life support system or electrolysis for propellant production. Within our project, we really look into this middle frame that's here shown here. And since we are not on the moon and we don't have a real water ice deposit here on Earth, we substitute that with a water ice regolith simulant that we use to simulate the lunar surface and the conditions on the lunar surface to test our water extraction technology. And as you see, after each step, we will do condition and quality measurements. We will also investigate the residuals of the different processes to get a good idea of what happens after and in between each process step. And we are not starting from scratch. Within our project consortium, we already have a lot of background and some technologies that are already being developed or have been developed in other projects. So for example, I start in the top part in the middle. There's a very good dirty vacuum chamber at the Technical University of Braunschweig, which we will use for our project. But you will hear more about that from the people directly later. Also at Braunschweig, we can produce very fine-grained ice particles and mix that with regolith simulants to create this water ice regolith simulant for testing the extraction part. At DLR, we have started last year developing concepts for water extraction technologies, which have been gone very far until now. And we have several very good options from where we can decide. And we will do a detailed technology trade-off and then selecting one candidate that we will build for this project. There are also breadboards and technologies available at Thales Alenia Space in Italy for the water purification part. So there we also have hardware from where we can learn and that might be used within our project. And the same goes for water storage, where Thales Alenia Space also has developed already space hardware in that direction. In terms of the project schedule, the project is very, very tight and short. So we only have 2 years to achieve all our goals. And the project is divided into 3 phases. The first one already starts now, basically today with this kickoff meeting, where we start with requirements definition for our experiments, for our hardware, and also with the preliminary design of the subsystems and also of the experiments that we want to do later in the project. Early next year, February, March, the next phase starts, which is the more or less the longest phase in the project, where we do detailed design of the different subsystems and the experiments. We start the manufacturing and the procurement of the hardware, and also we developed the ice regolith simulant and also a lunar raw water simulant. So both simulants are necessary for our experiments. The ice regolith simulant is necessary to test the water extraction technology. And the lunar raw water simulant is required to do checkout tests on all the different quality and condition monitoring systems, but also on the storage and water purification subsystems. Followed by that, starting in 2024, we will do the technology validation campaign. So which means we will validate all the different subsystems in a relevant environment inside a dirty thermal vacuum chamber. Those experiments are going to be done at the Technical University of Braunschweig. We will evaluate the experiment results, and based on that, we will also investigate how our results can impact future developments for terrestrial and space applications. And as you see, that is a lot of tasks for just 2 years, but I'm very confident that with our project partners that we can do that. How does it look like, or what's the outcomes and the impacts of the project? Well, I can't look into the future, but that's at least what we envision or what our goals are for this project. So we will provide the direct results of the project. So in the frame of 2022 to 24, we will have validated subsystems, technologies for water extraction, purification, and condition monitoring. We will have the developed simulants for ice regolith and lunar raw water, which can then also be used by other people for their experiments. And we will have the direct experiment results from the validation test campaign. After 2024, so the medium-term outcomes that we can envision from this project is that we then further develop the technologies and the hardware towards a flight-ready hardware. So really taking the next steps after doing the tests in the thermal vacuum chamber to further develop the different subsystems. And we will provide all the simulants and simulant recipes, data, etc., for other research groups so that they can do excellent science. The long-term impact that we envision, or that's our goal, that we provide Europe with innovative ISRU technologies in this field, so in the field of lunar water utilization. And we also hope that by further developing our technologies, that one day we can contribute to a European lunar exploration mission, for example, in terms of a technology demonstrator also, or something similar, for example, for the European Large Logistics Lander missions, which start in 2030. We will also communicate our results and our progress of this project. So there will be a project website, which is luwex.space. Right now it's still under construction, but it will be going live in the next weeks. You will see frequent press releases about our progress. We will do a podcast and a videocast mini-series where you can follow the project, but also individual researchers in their work. There will be, at the end of the project, there will be a summary brochure, and you can also follow individual researchers and also the social media profiles of the different research partners in order to get updates on the current state of the project. And we will also do, of course, publish all our results, which is an important part of a European funded project, that all data, all results are going to be publicly accessible. So you will have access to all of our results in terms of publications, but also data sets and so on. And if you visit space conferences frequently, you will probably see a poster and a presentation from one of our researchers during those conferences in the next 2 to 3 years. Our project team consists of 6 partners all over Europe. We have the German Aerospace Centre in Bremen in Germany, where I'm working. Then we have the Technical University in Braunschweig, also in Germany. And then we have in Poland, Scanway company, and also the Wrocław University of Science and Technology. In Austria, we have LIQUIFER Systems Group joining the team. And in Italy, we have Thales Alenia Space in Torino. As you can see, we are a very mixed team, very diverse team. We have industry, we have research organizations, but also academia in the team. We have partners with a very, very year-long experience in building space systems, but also partners who just recently entered the space area. So that also helps us to bring together a very multidisciplinary team with different backgrounds in terms of knowledge, but also culture, language, etc. So a truly European project in that sense. And I'm very happy to have all of those in the project. And I'm very happy that we can work together in the next 2 years. And in the next presentation will be that all the different partners will introduce themselves so that you can all get an idea who is in the project, what are the people behind the project, and what is their expertise. And with that, I will conclude here the project overview. I will put on the next presentation. And I think the first speaker is René from LIQUIFER Systems Group.
Yeah, hello everybody. Can you give me permission to share my screen? Or are you presenting?
I would present and I just click forward.
All right. Okay, so good morning, everybody. I'm René Wacławicek, Managing Director and co-owner of LIQUIFER Systems Group. LIQUIFER is an interdisciplinary platform with a focus on architecture and design for extreme environments. Maybe you can go on clicking,
yeah,
if you don't mind. Yes. No, this is actually not.
Sorry, it's the wrong. Yeah, just a second. This
all
one
right.
is the first
Okay.
slide. Sorry.
So LIQUIFER was founded in 2004 in Vienna, and since 2019 we have another branch in Bremen. LIQUIFER is led by Barbara Imhoff, Waltraud Hoheneder, and myself, René Wacławicek. We are particularly interested in human space exploration, and since almost 20 years, our research and development activities are ranging from concept studies to prototype building. One could say our vision is to establish sustainable, permanent human presence in space, be it in orbit or on celestial bodies like the Moon, Mars, and beyond. Can we see the next slide? So this is the project team. I already mentioned Barbara Imhoff, Waltraud Hoheneder, and myself, René Wacławicek. We are the managing directors and co-owners at LIQUIFER. Within the LUWEX project, I will be responsible for LIQUIFER's to coordinate LIQUIFER's activity. Then there is Bob Davenport. He joined LIQUIFER as an internal consultant in 2013. Bob is a space system engineer with a master in material sciences and more than 40 years of experience in the industry. Chris also joined LIQUIFER as an internal consultant in 2013 with his background in engineering and business and administration. And like Bob, Chris gained extensive experience during his career in working for European and international space activities. And last but not least, Monika Brandic-Lipinska. She's our youngest and newest team member. She holds a master in architecture and space studies, and since 2020, she has been internal consultant at LIQUIFER, besides pursuing her PhD at the Hub for Biotechnology in the built environment at Newcastle University. So when we look at the next slide, so this was our team. As next slide gives a quick overview over our tasks. So one task will be the system requirements and interface analysis. That means we will define and compile all system, subsystem, and interface requirements for the validation test setup. Similarly, we will do the same for a future notional flight model with respect to dimensions, mass, power, thermal loads, regulatory characteristics, and etc. We will also investigate the requirements on the water quality for the propellant production and life supports potable water. And we will define all of the external and internal hardware and software interfaces. The other work package we're responsible for, Paul mentioned it before, is dissemination, exploitation, and communication. This comprises, as said before, a website, project flyers, press releases, of which the first one has already been written and will be published within the next days. There will be a podcast and a videocast miniseries, a summary brochure, and at the end of the project, we will produce a project video. And apart from that, we will write conference papers and presentations for fairs and exhibitions. Thank you, Paul.
Thank you, René. Very glad to have you all in the team. And the next on the list is Thales Alenia Space, and I think Giorgio is presenting that.
Yep, can you hear me?
Yes, it works.
Okay, thank you. Good morning, everybody. I'm Giorgio Boscheri from Thales Alenia Space. Thales Alenia Space is a multinational company that works on space, and we have more than 8,000 employees in 18 sites worldwide. We are widely involved in many fields of space, from telecommunication to observation to communications. But in our Torino plant in Italy, we are focused on exploration and science. We have here our domain exploration and science, and here we are deeply involved in all the exploration efforts. For example, from Torino comes more than 40% of the habitable volume of the International Space Station. We are right now building the first commercial station for low Earth orbit, and we are also one of the key forge for the Lunar Gateway, for the IHAL module, the ESPRIT, and so on. So we are deeply involved in the lunar exploration part, and also we do work for Mars exploration, for example, the ExoMars project that most probably know. Next slide. Our key responsibility is related to water purification within LUWEX, and we do have some valid experience that we'll be counting on to carry on this project. We have an internal R&D project dedicated to recovered condensate from the astronaut and urine regeneration. So the worm kit system is a system we are developing with internal funds to be a future product for commercial space stations. We also produced a few batches of the water that the astronauts drink on space station. Actually, the cosmonauts, it was the water that the Russians use, adding silver. We also already in the EC framework, when there was the H2020 framework, we developed a BioWise unit. Basically is a water dispenser where you can store and keep safe microbiologically wise water for long periods and always analyze it online for microbial contamination and provide a safe delivery to the crew. We already have been flying some space hardware related to water treatment technology in the advanced closed loop system that was made as prime contractor by Airbus, and we actually were key partners for the water management unit. So we develop multiple technologies that are now on space station within that rack. And also we do work, and we do have a lot of experience with collaboration in the past with DLR for greenhouse technologies, and within those greenhouse technologies there are water purification technologies within the recovered condensate from the atmospheric water vapor, as well recovering nutrient solution for plants. So we have some recent relevant background that will be used for this project. Next slide, please. We have two levels of responsibilities. At subsystem level, we are the responsible for the water treatment. So after the liquefaction phase, we will do the treatment to remove the contaminants to get to the target qualities. And so we will do that from the design to the production of the breadboard and the preliminary testing, and then support the test in the overall breadboard. And at system level, since we are by nature large system integrators, we also do have some responsibility in technical coordination of the overall breadboard aspect and support of the overall test campaign. But most of all, we will support the team on understanding how our breadboard could evolve in the future to become a real space mission. The core team is here on the right. We have our coordinator internally, Giorgio Musso, is responsible for multiple Horizon Europe projects, as well as advanced exploration projects. I will be the technical coordinator of this effort. And the process engineer will be Rachele Perelli to the right. She's a chemical engineer, so she will use her knowledge in the water treatment processes and on multi-physics modeling to support the project. And Giovanni Marchitelli will be our test engineer and will also support the procurement. And Thomas Fili will cover all the automation aspects and all the wiring and control and acquisition part of the breadboard. That's it.
Thank you, Giorgio. Next on the list it's me again. So DLR is the Federal Republic of Germany's Research Center for Aeronautics and Space. DLR is doing a lot of research and development activities in the fields of aeronautics, space, energy, transport, security, and digitalization. DLR operates several research institutes, the German Space Agency, and 2 project management agencies which oversee funding programs, especially national funding programs. And DLR has more than 10,000 employees in 55 research institutes and facilities in more than 30 locations in Germany. Part of this project will be the Institute of Space Systems, which is located in Bremen in northern Germany. And this institute was founded in 2006. It has right now around 140 employees. It's a multidisciplinary engineering research institute. So we have capabilities for really doing engineering on space missions and also space technologies. The institute is also the competence center for system analysis and system development. Some former projects that have been developed in this institute are, for example, the Mascot asteroid lander, or the Eden ISS Antarctic greenhouse testing life support technologies, or the HP3 experiment, which was on the Inside Mars lander. But that are only 3 concrete examples. The Institute has done many, many more projects in the last almost 20 years that the Institute exists. Within this Institute, my research group will be working on this project. We have expertise in situ resource utilization and life support system technologies. We also do feasibility studies of ISRU systems, and we do more concrete technology developments in the field of regolith beneficiation, water extraction, and water purification. The group that is part of this project is called the Synergetic Material Research Group and consists right now out of me, 2 PhD candidates, and typically 3 to 5 students. For this project, we are also joined by 2 concurrent engineering experts and one administrative employee. So you will see a photo of me over there. Then Rika and Luca are the 2 PhD candidates working in the field of water extraction, purification, water infrastructure for lunar habitats. Dominic and Antonio are going to be running the concurrent engineering study for the preliminary design. Ines is responsible for all the administrative work around this project, and Kunal and Victoria are 2 of our students that we have right now in our group. Within the project, DLR will be the coordinator and will also do the project management. We will do the concurrent engineering design study to establish the preliminary design of the subsystems and the overall breadboard. And within the subsystems, we are responsible for the water extraction subsystem and the liquefaction subsystem. In the more research-oriented work packages, we are responsible for developing the lunar raw water simulant, which will be then used, for example, for checkout tests on the purification subsystem and the quality monitoring. We will also participate in the validation experiment campaign. And of course, we will also assist the dissemination, exploitation, and communication activities. We also have capabilities in terms of laboratories for this project and also this DLR's concurrent engineering facility. Next in the list is Scanway from Poland. I think Mikołaj, are you presenting?
Yes, I'm here. I'm presenting. Good morning, everybody. My name is Mikołaj Podgórski. I'm a board member of Scanway, and let me tell you a few things about us, about our company, and about our role in LUWEX. So basically, we in Scanway, we consider ourselves as leaders of not only Polish, but also Central and Eastern European market in terms of the optoelectronic payloads and optical R&D in general. We focus on optical payloads for space. We focus on cameras and vision systems for manufacturing, not in space, but on ground. So we try to combine these unique competences that we have from, let's say, regular industry where we have to deliver products in a very short manner. And we try to transfer that technology and that approach to the space projects that we have. And we have lots of optical payloads contracted for next years. We also are very active in this camera society, both for space and for ground. And basically, our core competences lay in optics and in designing of different optical and laser systems. Next slide, please. We are on the market for more than 6 years. Currently, we have like 47 or maybe 48. I don't recall, to be honest, employees, engineers mostly. We will have a dedicated team of engineers, including me and our CEO, Jędrzej Kowalewski, to work within the LUWEX project. And this unique blend of expertise that we have from normal industry, from academia, or from R&D activities will help us to go through the LUWEX and deliver the work packages that we are doing. And the next slide, please. And within the project, we'll be delivering the one of the systems for quality inspection of the water. The system is working on the principle of laser-induced breakdown spectroscopy. Basically, it means that we'll shoot a laser to the water. We'll have the particles in plasma state, and with the use of spectrometer, we'll be looking at what is the composition of the ablated particles. So we've been implementing that system in Polish universities and in Polish mining companies. And we've been also conducting tests with this kind of equipment on real meteorites that we've had from one of the universities. So it's the system that not only was used by us, but also, of course, is currently present on the Mars on board of different rovers. So we'll be delivering that inside the project, and we'll be also trying to go with a technology plan to improve the TRL and make that equipment smaller and more affordable to put it on the moon actually in the future. So thank you. That would be all from me, at least for now.
All right, thank you, Mikolaj. Next one is the Technical University Braunschweig, and Jürgen, it's your turn.
Thanks, Paul. Good morning. My name is Jürgen Blum. I'm a professor at the University of Technology Braunschweig. So actually, the translation Technical University is not allowed. So if it has to be translated into English, it's University of Technology, or in German, Technische Universität Braunschweig. The location of Braunschweig you see on the map on the right-hand side. It's actually not so far from Bremen. It's a mere 2 hours by train and 1.5 by car if the highway is empty. It's close to Hanover and also not far away from Berlin. So it's in the northern half of Germany located. TU Braunschweig is the oldest university of technology in Germany. It was founded back in 1745, so it's very old. And it only became renamed as a university in 1968. And since then, we've been calling us TU Braunschweig. We do have 84 degree programs in all kinds of fields. And the university consists of 6 faculties, and myself, I am in faculty number 5. It's the Faculty of Electrical Engineering, Information Technology, Physics. And I'm, of course, in the physics part of it. We're a middle-sized university. We have about 18,000 students and 240 round professors and scientific staff of about 2,000 people. Next slide, please, Paul. My institute is the Institute of Geophysics and Extraterrestrial Physics. The institute was established in 1959. Back then, it was named Institute of Geophysics and Meteorology. And when I joined TU Braunschweig in 2003, we shortly afterwards renamed the institute to Institute of Geophysics and Extraterrestrial Physics, because my profession is extraterrestrial physics. We have currently 5 active professors. We have a few retired and a few external professors as well. It's Professor Agarwal. She does solar system astronomy. My main field is planet formation and small bodies, including the moon. We have junior Professor Bücker, who does urban geophysics, Professor Hurt with applied geophysics, and Professor Plaschke, who teaches space physics and space sensorics. The staff is currently 32 at the institute within the 5 groups. And we do have technical and administrative staff also, and numerous students. So all in all, there are 50 to 60 people in the institute currently. We take part in our BSc and MSc programs in physics, and of course in the doctorate program as well as the university. And in 1 year from now, we will have started a new master program in solar system physics, in which we take the leading role. Next slide, please. The team is actually a team of 3 staff people that you see on the right-hand side. It's myself. I basically do the coordination work. Christopher Kreuzig, who will talk in the afternoon, is our expert on the simulation facility. So he'll be responsible for all the experimenting in the LUWEX program. And Johanna is responsible for numerical simulations if they are required. So she overlooks our numerical simulations group. Our experience and expertise is within astrophysical and planetary science experiments mainly, plus recently some thermophysical modeling. We do have many experiments running at the institute. We have our own labs, different labs. You see the details here. I don't want to read out all of them. Important for the equipment is we have this large cryo vacuum simulation chamber that we will be using for LUWEX. You have seen a picture already of it. And I think there on the next slide and last slide, there is the same or an identical picture as you've seen before. So all we do is taking part around this or inside this chamber. So we, as a background, we will be responsible for the analysis of the lunar data. So what is our current knowledge on the real abundances? So we will take part in that. We will be responsible for the development and the provision for the lunar icy regolith formation of the ice particles. So you see here a spoonful of microgranular water ice samples. They're micron in size and spherical, very nice and fully characterized particles. And on the experimental part, we will adapt our system to the LUWEX conditions. We will prepare, host, perform, and analyze the campaigns that we will drive for LUWEX in our thermal vacuum chamber. And of course, we will also be co-responsible for any exploitation, scientific, engineering, whatsoever results of the experiments. And I think the last, no, I think that was my last slide. Yeah, thanks a lot.
Thanks a lot, Jürgen. And Carol will present our last partner.
Yes, thank you, Paul. Hello, everybody, once again. So I am Karol Leluk. I represent Wrocław University of Science and Technology. And just a history at a glance, the University of Science and Technology was established by the Emperor Wilhelm II, and it started its activity in 1910. Since then, we are developing, and our last achievement was we united with the Unite network of universities in Europe. Paul, could we go further? Thank you. And today I represent the Faculty of Environmental Engineering, being here a Vice Dean for international cooperation. And the Faculty of Environmental Engineering is connected with, okay, in one word, with everything which is sustainable. So we've got, during the recruitation of our students, so we've got such a keywords: zero waste, zero emission, and zero energy. And yeah, the next click, please. Besides of that, we try to stick to the industry. So we make agreement with hidden power plant, the biggest one in Wrocław, I think in the voivodeship, Lower Silesia and voivodeship Kogeneracja. Please. Also, we try to stick closely to our Ministry of Climate and Environment. Here's one of our professors. Yeah, with we also attend the Polish National Cluster, which is a key cluster of waste management and recycling. And next click. Yeah, and our students take part in Climathon, in so-called hackathons, just to expand the knowledge all around the sustainable factors. Please go further. Yes, one click. And of course, we are not only to the so-called environment, we also try to go to the networks, the water networks, urban networks, and the heat distribution. Please, next. Yeah, and this is the example of one of our project. There's this, I should say, the habitat. Yeah, this is there's a just a motorhome in which we design all the facilities related to heat management and water management, wastewater management. Of course, here where you see this Volkswagen, we also made an 8-hour instant transmission to the it was a broadcast to the TV while we measured the internal condition in the vehicle during the really hot days. So how they are changing, how they are affecting the internal safety, internal environment. Okay, please go further. And of course, one of ours, we have got also a bee plant. So we monitor how the bees are behaving during the changing in our environment. Okay, so I'm showing this because our next step is move forward to space, thanks to Paul Zabel. So now the Faculty of Environmental Engineering is moving to space. Please, let's go further. And yeah, our team. As in the project, we are related to the task called the water quality and condition monitoring, and of course, overall system assembly and integration. So our task consists of several people. The first one from the left is Ola Klimonda, which will be our laboratory support. She will be responsible for all water quality measurements. Then is Sławek Szczerzyna, which is a PhD from our faculty. He has a huge experience in the private sector, of course, working on the membrane processes of water purification. He has experience also in the municipal water and sewage company. Together with Ola Klimonda, which unfortunately her photo I do not have. And the next person is Ania Jurga. Okay, she is really keen on space mission related projects. So all the utilization of fertilizers, bioreactors, gray water, reuse in processes and technologies, also her PhD. She's a fresh PhD now. So all her PhD was related to space tech, space innovation. Of course, she takes part in a Women in Aerospace Association, as a workshop, and many other things. Yeah, and the last guy, it's just me managing the project. So thank you very much for your time. And if you have any questions, I willingly will answer. Thank you very much.
Thank you, Carol, for presenting. So now you have a very good overview about the whole project team and what we are going to do, or what we plan to do, and what we try to achieve.